Guys, okay, next video today. Now we're going to continue with the next learning objectives. This is like a simpler one. So we are going to define the term hybridization, state the type of hybrid orbitals. You have 5 here, and then predict the type of hybridization at the central atom. Alright. So recall from the last video, we will meet hybrid orbitals soon. So we need to know what are hybrid orbitals and how do we do them with hybridization. Okay. So first of all, what is hybridization, guys? Okay, saya tengah dengar ni. Sila bagi tahu saya, pernah dengar perkataan hybrid tak? So hybrid cars, hybrid plants, hybrid animals. So you're going to mix stuff and get a totally new, let's say animal. Okay. So in chemistry, hybridization is the process of mixing atomic orbitals in an atom to form a new set of hybrid orbitals. Okay. So, what are these new set of hybrid orbitals? They have, apa yang special ni? New set of hybrid orbitals have equivalent shape and energy. Okay? So, but why? Why do we need to form hybrid orbitals? If you recall your, what we learned from chapter 2, was it? So, what's wrong with your pure atomic orbitals? Kenapa tak boleh? So, your pure atomic orbitals, you have S, P and D, right? So, your S orbital is a spherical shape, your P orbital is a dumbbell shape, your D orbital is a cloverleaf shape. Or lagi satu, donut, right? Yang ni, DZ square. Okay? So, your pure atomic orbitals, they have totally different shapes, alright? So, they have different shapes. And another thing about your pure atomic orbitals in your atoms, they have different energies. Okay? Totally different energies. So, different shapes and different energies, it is not efficient when you want to overlap your orbitals later. So what I'm going to do is, I'm going to hybrid. I'm going to mix my orbitals, my pure atomic orbitals. Let's say, I'm going to mix 3s, one 3s orbital and one 3p orbital in order to get new hybrid orbitals. Totally new. Okay? So these new hybrid orbitals, they will have the same energy and they will have the same shape. So with same shape and energy orbitals, hybrid orbitals, you will get an efficient orbital overlap, guys. Okay? That's why we need to hybrid our orbitals. So, okay. Story time! So, hari tu, I wanted to paint the living room wall purple. And then tiba-tiba tak cukup pula purple paint tu. Okay. So what we did was, I bought blue paint and then my housemate, she bought red paint. Okay. So what did we do? We mixed those two paint together. Guess what color did we get, guys? Purple. Wow. Okay, purple color. Not just that, I got 2 tints of purple colour back. So, I mix these 2 colours. Oh, mak kau. Allah, astaga. Okay. So, I mixed these 2 colours and I got a totally new colour. Alright? And not just that, I mix 1 tint with 1 tint. I got back 2 tints. Okay. Surprise kan? Okay. So, in chemistry, we are going to mix our pure atomic orbitals to form hybrid orbitals. Okay. So the first hybridization process that I'm going to show you is sp hybridization. Okay. Can you read my mind? What pure atomic orbitals that I'm going to use? Okay. Hint dia, from the name, you can already tell. Okay. Okay. So, the pure atomic orbitals that I'm going to use is 1s orbital and 1p orbital. Okay. And then, I mix those two pure atomic orbitals together and hybridize them, and I will get back two sp hybrid orbitals. Okay. Tengok look at the shapes. The shape of these new hybrid orbitals, they are the same. And they also have the same energy. Alright? And also note that this is the standard shape of your hybrid orbitals, okay? So since I mix one s orbital and one p orbital, I get back two sp hybrid orbitals, okay? So two pure atomic orbitals akan dapat balik two hybrid orbitals. Okay. That's not the end of it. Your hybrid orbitals, remember VSEPR? They will arrange themselves so that they minimize the repulsion. So in these hybrid orbitals, nanti you will have electrons, right? So they will sit as far apart from each other as possible. So then it will be in the shape of linear shape. Okay. So they are directional, so they will orientate themselves this way. And note that you don't see the small lobes here. Okay, you only see the large lobes because the small lobes are hidden behind them. Okay, so that is sp hybrid orbitals. You get back two. So this is sp, this is also sp. Okay? Okay, next. Okay, read my mind. Cepat. sp2 hybridization. Agak-agak what pure atomic orbitals will you be using? You'll be using 1s orbital and 2 p orbitals. Okay, so I'm going to mix those orbitals together, hybridize them, and I get totally different, totally new sp2 hybrid orbitals. I get back 3 because I mix 3 pure atomic orbitals. So now, my hybrid orbitals, they are of the same energy and of the same shape. And due to VSEPR theory, they're going to orientate themselves so that they are as far apart from each other as possible to minimize repulsion in the shape of trigonal planar. Okay, trigonal planar. See, it's on one plane and you have 3 sp2 hybrid orbitals. Ni sp2, ni sp2, ini pun sp2. Okay? Okay. Next, let's try hybridizing these pure atomic orbitals. So the first one, you have 1 s orbital and you have 1, 2, 3 p orbitals. So what is the name of your hybrid orbitals, guys? What's the name? sp3 hybrid orbitals. Okay. Since you mix 1, 2, 3, 4 pure atomic orbitals, how many will you get? You will get 4. And the shape of your sp3 hybrid orbitals will be tetrahedral. Alright? Ingatkan from subtopic 4.2, tetrahedral shape. Okay. Next, if you have 1 s orbital and 3 p orbitals and 1 d orbital, you will get back sp3d hybrid orbitals. How many? 5. In what shape? Trigonal bipyramidal. Okay. Next, you will get sp3d2 hybrid orbitals, and there are 6. Alright, in the shape of octahedral. Okay, Boleh? Boleh? So, yang tetrahedral ni sp3 kan? So, ni sp3, 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 sp3. Okay? So, these orbitals are of the same shape and energy. Okay? Therefore, you will get more efficient overlap later. Alright, so now we're going to learn how to predict the hybridization of the central atom. So here you have CCl4 molecule and your carbon is the central atom. Okay, how do we predict? What should we do? We will have to count the number of lone pairs and the number of atoms bonded to the central atom. How many atoms around it? Atau how many sigma bonds. Alright? Okay. So, because maksudnya, these two will determine your type of hybridization, okay? So, if you look at carbon here, do you have any lone pairs? No, opsoyo, 0. So, how many atoms around it or how many sigma bonds? You have 1, 2, 3, 4. So, sigma, 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 sigma. So, you have 4 bonds. So, that means your carbon will have sp3 hybrid orbitals. So, the type of hybridization at carbon central atom will be sp3. Okay? Okay. So, if you total up the number of lone pairs and the number of bonded atoms, if you have 2, you will get sp hybridization at your central atom. Contohnya BeCl2. If 3, you will have sp2 hybridization. And so on. Okay? So, nanti when we want to draw our orbital overlap, we will count the number of lone pairs and the number of bonded atoms atau number of sigma bonds. Okay? So, for example, if you have, what did I do? Okay. CH4 molecule, from the Lewis structure of CH4, you can tell how many lone pairs, how many sigma bonds there are around carbon. So in this case, you have 4 sigma bonds, right? 4 sigma bonds, only 0 lone pairs. That means your hybridization will be sp3. So you'll have sp3 hybridization at your carbon. So sp3, you will have 4 loops. 1, 2, 3, 4. So sp3, sp3, sp3. Okay, nama dia. So itu carbon nanti. Alright. So NH3 pula. Draw the Lewis structure. Okay, so how many lone pairs you have? You have 1 lone pair. And you have 1, 2, 3. 3 sigma bond. That means that's 4 total. So you will have sp3 hybridization at nitrogen as well. So, just like CH4 just now, the difference is you're going to put lone pair at one of the loops, one of the sp3 hybrid orbitals. Okay? Yang lain available for bonding. Okay? Okay, next. For CO2. What did I do, guys? Oh, shit. Oops, sorry. So, carbon. Minta maaf. Oxygen. C. So, at carbon, tengok tu, ada double bond kan? Tapi, we will only take account of your lone pair and sigma bonds for the hybridization type. So you have 1 sigma, 1 pi, 1 sigma, 1 pi. So around carbon, you have a total of 0 lone pair and 2 sigma bonds. So that is 2 total, meaning you will need 2 hybrid orbitals, namanya sp. Because sp, you will have 2 sp hybrid orbitals, kan? So the shape will be like this, linear. So this is sp, this is sp, and you have carbon here, right? Macam tu. Okay. C2H2. Okay. Let's look at just one of the carbons. Okay. So let's look at this carbon. So at this triple bond here, you have 1 sigma, and the other 2 are pi and pi. And you have another sigma, right? So at carbon, you have you have 1, 2 sigma, 0 lone pairs. So that's a total of 2 as well. Okay, so maksudnya the type of hybridization at carbon will be sp hybridization. So the shape will be the same, sp, sp, and then carbon. Alright? Okay. Boleh? Nanti do your tutorials. So let's see. So kita summarize now. So the first one we covered is that hybridization of atomic orbitals is the process of mixing atomic orbitals in an atom to form a new set of hybrid orbitals with equivalent shape and energy. Next, we now know that we have 5 types of hybrid orbitals. sp, sp2, sp3, sp3d, and sp3d2. Another thing that we covered is the type of hybridization, predicting the type of hybridization at your central atom. So, how do you predict? You will have to count the number of lone pairs and the number of atoms bonded, or I like to say the number of sigma bonds. Alright, so Alhamdulillah, we are halfway there in 4.3. So let's get it, guys. Buat tutorial, okay? Bye. Good night. Thank you. Bye-bye.